Architectural technologists have a responsibility, and because we have an understanding of the whole construction process, and because we have an understanding of all the technologies that are available to bring to the design and construction process, we're the ones who can make sure that the built environment of the future is really fit for purpose. The makeup of an architectural technologist, they're interested in the design, but they're interested in the science of the building as well. And so they're able to bring those two things together and create a really aesthetically fabulous design, but it's going to function and perform. That's what's ingrained into you as an architectural technologist. That's what you do. The architectural technology is right on the cutting edge in terms of materials, technology, and process. The start of any project is around capturing information and data about the site that we're going to be working on. So we can make use now of terrestrial laser scanning technologies. We can measure sites that we're going to be working on, and that gives us three-dimensional data which we can start our design on, and that three-dimensional data is far more robust and far more accurate than anything that we've had in the past. We use drone technology, and that in itself gives us a completely unique view of the site. Not only do we get more information about site constraints, site topology, we can also use techniques such as photogrammetry to generate three-dimensional data from those aerial images. We use building information modeling tools, BIM tools, examples such as Revit or ArchiCAD or various other tools that exist. And we design in 3D. Because we work in 3D now, we can take games engine technologies, for example Unity or Unreal Engine. It allows us to immerse ourselves inside that 3D design and make judgments on that 3D design based on a unique viewpoint that historically we haven't had. We can test it from a functional point of view, but we can also test the materials. So we might test the thermal performance of the building, simulate how the building will perform in terms of its energy, and that's a big thing for us now, obviously. Or we might test how human traffic flows through the building. We do physical testing, so we can test the materials, and we can make sure that that matches what we see in the virtual model, so that we can make sure that what we actually create is fit for purpose and is the best possible outcome for the client. It gives the client an opportunity to engage with that building much earlier in the process. Omnidirectional treadmills, which give a very intuitive way to navigate the 3D building. Augmented reality technologies as well, so we can go into a site and visualize and overlay the computer model onto the real world so that they can see what will be there in the future. We still want to make 3D models. Now sometimes we 3D print those. We still need to be able to build models by hand as well. That skill, I think, will always be there. Bringing technology to bear on the whole process opens up a whole new world of being able to make sure that these buildings work for us, and it gives us certainty. And whenever we have certainty, that's value. We need people with talents that are able to see the future and want to use the tools of the future to make a better built environment for us. How we engage with buildings is changing. Our way of working within the built environment is changing. And so as architectural technologists, we get to be at the sort of precipice of that change. And actually we get to influence that change as well. We can bring new technologies to buildings, we can bring new technologies to the design process, and we're the ones who are right on the cutting edge of that. And that's exciting.